Hello and welcome back to IXL tutorials. This is Mr. Duffick and today we are doing IXL M3, which is titled Identify Medians, Altitudes, Angle Bisectors, and Perpendicular Bisectors. So these questions are just a series where they give you a certain triangle and they ask you to identify a certain segment in that triangle. So there's four that you need to understand, which are in the title, which are medians, altitudes, angle bisectors, and perpendicular bisectors. And what I did is I grabbed the little guide from IXL and it defines each of our vocab words. So a median is a triangle of a triangle is a segment connecting a vertex to the midpoint of its opposite side. An altitude of a triangle is a segment from a vertex to the line containing its opposite side and is perpendicular to that line. An angle bisector divides an angle into two congruent angles, and a perpendicular bisector splits a segment into two congruent segments and is perpendicular to that segment. So instead of drawing out diagrams for you to show you what that is, I'm just going to do a lot of problems here and show you kind of the difference between those four in these examples. So look at the diagram. Which term describes IG? So it describes this right here. Well, an angle bisector is a line that cuts the angles here into two congruent angles. And there's no indicator that these two angles were just cut in half, or this angle is cut in half into two equal ones. If there was a single ring on both sides, for instance, or maybe two rings on both sides, that would indicate the angle was cut in half, so that's not the case. A perpendicular bisector is something that might cut a segment, but it has to cut it in half. So it's very clear that that FG and GH are not two halves. They don't equal the same thing. We would know this if there was a tick mark or maybe two tick marks on each side or something like that, indicating they were congruent. So these two are definitely not cut in half, so they are not a perpendicular bisector. The altitude connects the vertex to the other side and the line is congruent, or not congruent, sorry, perpendicular. So this line is going to be perpendicular to the segment it hits, which looks like is the case, right? We have a 90-degree angle, meaning these two lines would be perpendicular. And a median is a lower version of that where this line is going to hit this line, but it's not necessarily going to be perpendicular like it is here. So altitude is going to be the best way to describe this triangle. Okay. So altitude, it's starting at the vertex, it's starting at a point and going to this side. Does it indicate that there is a perpendicular line here? No. These lines are clearly not perpendicular, so not an altitude. Is it an angle bisector? Are we cutting this angle into two equal halves? No indicator there. Is it a perpendicular bisector? So is it cutting this entire line into two equal halves and is perpendicular? That's half true. It looks like it is cutting this segment into two equal segments right here, tick mark, but this line itself is not perpendicular, so it is not a perpendicular bisector. It might be just a regular bisector, but not perpendicular, which leaves us with a median. And again, a median is just a line that starts at this point, goes to the line segment over here. So median is going to be the closest thing we can classify this thing as. Okay, look at the diagram. What is XZ? So this line right here. Now this is a good example of when we do have the line start from the corner, the point, and go to the segment. You see that there are one ring. There is one ring on each side there. There are two rings. So that would mean this line cut this angle into two equal halves. So angle here and angle here, one ring, which means it is an angle bisector. We are cutting this angle into two equal halves there. Okay, so look at the diagram here, what describes US. Is it an angle bisector? No. Altitude? Yes, because there's that perpendicular and it's not cutting in half. Perpendicular bisector? No, because it's not cutting it in half. And then none of these, so that is incorrect. Altitude. Okay, PQR is congruent to RPS. And which term describes PR? So QPR. So this one is congruent with RPS. So it's saying these two angles are congruent there. So what is PR then? What's going to happen here? This is actually going to be an example of an angle bisector because we have the two P's are congruent, QPR, so QPR, so we know this is congruent with this, right? The two P's correspond, so the angles are going to be the same, so it's going to be an angle bisector. Okay? Which term describes DF here? DF. Definitely not an angle bisector, definitely not an altitude. So it's either a perpendicular bisector or none of these. It's not a perpendicular bisector, so none of these. Okay, we need to see a perpendicular bisector at some point. Okay, look at the diagram. Which term describes this? Just a median. Again, we might be cutting these two in half, but it's not perpendicular. Okay, CDF, CDF. So right here, this angle is a right angle, and DE and CD are congruent. Okay, here's one. So which term describes DF right here? So it's saying these two are congruent. It's not showing the tick marks, but there are tick marks there. Tick mark here, and it's saying this is a right angle, meaning this line right here is going to be both perpendicular because there's a right angle, and also it's going to bisect this entire segment because these two are equal, right? Therefore, it is going to be a perpendicular bisector. It's not going to be an angle bisector. There's no angles being bisected. It is more than just a median because we have that 90-degree angle there and the two congruent halves here, and then it's not none of these. So that is a perpendicular bisector. Good, we found one. Okay, so this is where I'm going to end the video. Stay safe, take care. See you later. Goodbye.